This week on the show, we cover the FuryBSD 2020 Q2 report and the images that are available this way. We have a list of technical reasons to choose FreeBSD over GNU/Linux. The Ars Technica article about the GhostBSD review is what we're looking at. Then we tell you about the TLS Mastery sponsorships that are now open and you can support if you like. The BSD community showed their various collections, and we covered a couple of the posts that people have sent to us. The tale of the OpenBSD secure memory allocator is what we tell you, as well as learning how to stop worrying and love the SSDs in this week's episode of BSD Now. BSD Now, episode 348, BSD Community Collections, recorded for the 29th of April, 2020. Hello, I'm your host, Benedikt Kreuzling.
And I'm Alan Jude.
Welcome to this week's episode of BSD Now, with fresh content and news for you. The headlines this week start with FuryBSD 2020 Q2 images available for XFCE and KDE.
So this is over on the FuryBSD website, a post by Joe Maloney.
Yep, this is a status report like the one we read last week about the Q1 FreeBSD project, but this one is from FuryBSD. And they write that the Q2 2020 images are not visible or are not a visible leap forward, but a functional leap forward. Most effort was spent creating a better out-of-the-box experience for automatic Ethernet configurations, working Wi-Fi, webcam, and improved hypervisor support.
Yeah, so FuryBSD is basically part of the team from the old PCBSD/TrueOS that have kept doing a BSD-based thing because the Project Trident went a more Linuxy direction. But yeah, they have improved guest editions for VirtualBox, VMware, KVM, and Zen, plus some improvements for Beehive too. And their new FuryBSD Wi-Fi tool.
Yeah, for that specifically, they write that they added the Wi-Fi tool to allow the user to select and configure detected Wi-Fi devices, which launches WPA GUI for user with the selected device when there are multiple Wi-Fi devices. And it does the HCP CD, which will detect a new connection that has been established and automatically obtain the IPv6 and IPv4 addresses. There's plenty of cool things in the details of the announcement, so check it out and report anything to us about FuryBSD. Maybe you have used it for a while and want to, give us your experiences with us. Would be nice to hear more about this. Then next, our item we have in this show is technical reasons to choose FreeBSD over GNU Linux.
So this is a post over on unixshake.com. And it says, since I wrote my article, Why You Should Migrate Everything from Linux to BSD, I've wanted to write something about the technical reasons to choose FreeBSD over Linux. And while I cannot possibly cover every single reason, I can write out some of the reasons that I consider worth noting. So this is a post from earlier this month. It starts with an introduction. In my previous article, Why You Should Migrate Everything from Linux to BSD, Part 1 and Part 2, I addressed some of the political problems that have been going on in GNU Linux, and while I believe these issues are important and reasons to consider migrating from Linux to BSD, there also exist technical reasons to consider, the first being the clean separation. Because of the way FreeBSD has been designed and how the different components can be put together, you can deal with configuration and tuning and all the tools that have been developed and improved over many years. Whereas with Linux distributions I've been working with since 1995, you get a feeling of a mismatch sometimes. He goes into detail about that, but he also talks about documentation and the fact that one project means the documentation is more easily found in one place. He talks about some of the installation stuff and some of the security settings, looking at stability, and then the ports collection, the combination of having a base system where you get stable releases on a fairly regular schedule, but your packages, the applications you run, get updated very frequently, either your choice of the latest rolling release, which is every couple of days, or the quarterly branch if you want your applications to not change quite so frequently. But compared to some Linuxes where, if you want a certain programming language, whether that's PHP, Ruby, Python, whatever, the newest or even, server applications like Nginx or MySQL or whatever, the newest version you can get, if they're from 3 years ago, that's not especially helpful when you're trying to develop modern applications. So having that mix of long-term stability of the OS with rolling release of the packages gives you a very powerful combination. They also talk about Poudware and using that to be able to build your own packages so that you can customize things if you need to. Then they have more than an entire screen full on ZFS. And then even a separate section from that on boot environments and having the ability to, roll back your system if something does go wrong really helps a lot. Then they talk about the BSD style init and how nice sometimes having the RC scripts are compared to something more complicated like systemd. There are advantages to more complicated systems, but there sometimes is something nice about having a system you can understand all the working parts of it and keep that, the diagram of that in your head. Then it talks about jails and even a bit about Bastille, which is one of the jail managers for FreeBSD. Talks about Capsicum, dtrace, Beehive, all of the different firewalls, which is, often an issue there. And then it has a whole section on tuning and geom, Linux binary compatibility, the security auditing, and then another whole screen full of notes saying, this article is by no means an exhaustive list of technical reasons to use FreeBSD over Linux. Many other reasons exist, and I haven't addressed those. However, these are some of the features that stand out in their humble opinion. Unless you have a very specific need for Linux, such as a specific support for hardware, which, there's not that much hardware that's only supported by Linux and not BSD nowadays, then you can usually just choose to run FreeBSD. Situations where you might experience problems with FreeBSD are situations where you're doing something very specific or where the application is very Linux-centric. The maintainers of FreeBSD spend quite a bit of time making sure applications just work, and that's why there are 39,000 applications in the FreeBSD ports tree. They say they're running FreeBSD on both servers and desktop workstations, where I recently have migrated systems running ZFS on both Debian and Linux and Arch over to FreeBSD. I've experienced an increase not only in performance, but also in reliability because of the better integration that FreeBSD provides for ZFS. They're mostly using i3 as a window manager, and they say, it is a real shame that FreeBSD hasn't received the same amount of attention as Linux. In many cases, especially on production servers and in commercial usage, a company can gain much by running FreeBSD rather than Linux, and often the only reason they do run Linux is because of habits or because of the lack of general knowledge about FreeBSD.
We remember that this article, spurred a couple of comments, and also we asked, what are your experiences BSD versus Linux? And we got a couple of responses, which we covered a couple episodes ago. So maybe this is a follow-up and will spark interesting discussions in the same way. Okay, it's time we jump into the news roundup this week. We have a second Linux distro review, I would say, from Ars Technica. Remember the one from last week where we covered the one for FreeBSD, and now they looked at GhostBSD. So this is Jim Salter again, who's apparently doing a bit of BSD spelunking in various distros. So the subheadline reads, FreeBSD-derived GhostBSD welcomes users directly into a full desktop experience. So at the beginning, there's a bit of history. GhostBSD is based on TrueOS, which itself is derived from FreeBSD stable. It was originally a Canadian distro, but like most successful distributions, it has transcended into its country of origin and can now be considered worldwide. Significant GhostBSD development takes place now in Canada, Italy, Germany, and the United States. Then they talk a little bit about the turbulent history of desktop-oriented BSDs. There were a couple of attempts. For several years, Chris Moore's PCBSD was the go-to for, I want BSD, but I also want a ready-to-go desktop. Eventually, IX Systems, home of the FreeNAS storage distro and the company Chris Moore is vice president of engineering for, came to rely heavily on the server-side features developed into PCBSD. And so this eventually evolved into Project Trident in the next iteration of that. And yeah, a little bit about the histories and which led to further developments that include Fury BSD, Midnight BSD, Desktop BSD, and Ghost BSD itself. Okay, then there's a section about a live installation environment and how that goes and looks. Ghost BSD installation process is a pretty radical departure from FreeBSDs, although the underlying roots are still there. After defaulting or selecting multi-user boot, the user is presented with an ncurses ASCII menu showing or allowing X, the graphical display server configuration. It's a bit of a shame, they write, that the installer isn't yet capable of simply auto-detecting the graphics environment the way typical Linux installers do, but to be fair, the manual section could also make things easier for slightly wonky hardware. The option to fall back to simple VESA mode is staring you right in face. After all, should you try to direct Intel, AMD, or NVIDIA driver and fail. So they're doing the installation in the virtual machine again, like in the previous article about FreeBSD. And so they selected VISA, which is not the most best and highest resolution, but it's the most compatible with many of the virtualized graphics cards.
Yes, especially when running in a VM, you're not going to have, hardware accelerated graphics.
And so they start talking about the installation and how that feels like. So GhostBSD installation process is tremendously more straightforward than FreeBSD's. After double-clicking the installer, you're asked to select a disk configuration. Like FreeBSD, you're offered a chance for a ZFS root setup, including multiple disk topologies. They write that the mouse was, for some reason, extremely unresponsive and erratic in this menu and required significant patience. This is probably an artifact of the virtual machine installation. Probably so. I strongly suspect it would not have been an issue on bare metal. Yeah, so you have to take that in mind when you read things about performance in this article. So this is probably due to the virtual environment.
Well, actually, in the conclusion, they say that GhostBSD is a perfectly reasonable choice for a desktop distribution. While it may be behind some of the mainstream Linux counterparts in one or two places, they didn't encounter any real showstoppers. There was no obvious performance issues, and GhostBSD might in fact have been a little bit snappier than the Ubuntu 1910 that the host operating system was actually running it under. Audio worked out of the box, and once Firefox was installed, YouTube videos played very well. They say that Google Chrome didn't work under GhostBSD, but I don't know if that was just a temporary packaging problem or what. They said they liked GhostBSD's ZFS installer dialog much better than FreeBSD's, but it was deeply disappointed at its failure to honor its own forced ZFS 4K block checkbox, and that would have been a major stumbling block for performance on a real installation. I don't know what might have gone wrong there. I have to maybe find time to go look at the source for the GhostBSD installer and see what they're trying to do there. Yeah, say a veteran ZFS user could likely work around this issue, but there's an option right there in the installer, but it didn't seem to do the right thing. Absent a specific desire for BSD under the hood, I had a tough time recommending GhostBSD in place of one of the more mainstream Linux distros, but there's a pretty high bar. I would not have any issues recommending GhostBSD to a user, even a new to Unix user who specifically wanted a BSD-based desktop. Most of the few warts I found in GhostBSD are very fixable, and polish is clearly important to its community and its dev team. I suspect that the majority of the issues I discovered in this review will be fixed by the next release. So say the good was the installer is pleasant, efficient, and modern. The mate environment is well fleshed out and functional. The environment feels quick and snappy and doesn't feel laggy or sluggish. And going from zero to a desktop is possible even for very, very new users. As polished as GhostBSD is, it still lags behind some of the mainstream Linuxes, though. Support for proprietary user-focused applications like Chrome is great, but basically, if there's a package for it, it probably works, and if not, that could be a problem, yeah. And a new user who doesn't already have BSD friends might have a tough time finding support. And then they said the problems they encountered were Mate's top panel crashed at boot, and they were left wondering where the start menu was. Because it had crashed, not because it wasn't there, and the ZFS block size thing. And then finally it said the software station is primitive and difficult to navigate by modern standards. That can definitely be a problem with the ports tree. It's just with 39,000 items, how do you actually make some kind of navigation that makes sense? You either have to curate it down to a much smaller set, or the user has to know which software they're looking for already and be able to basically search. But anything that tries to let you just browse the ports tree looking for software is probably not going to end up great, because 39,000 applications is probably too many. And remember, GhostBSD is still a very fresh and young distribution, so they didn't have, of course, all the development years behind that other distributions from Linux had. But definitely an interesting review about the distribution, and if you haven't checked out GhostBSD yourself, you should definitely give it a try and report your findings back to us at feedback@bsdnow.tv. Next, we switch more into the book space. The TLS Mastery sponsorships are open on Michael W. Lucas's page, of course. We haven't heard from Michael in a while, although he has successfully released the SNMP Mastery with all the horrors that it contains. I'm currently reading it, so it's definitely a recommendation of mine. But this one is about TLS Mastery, and Michael writes, "My next book will be TLS Mastery, all about transport layer encryption. Let's encrypt, OCSP, and so on. This should be a shorter book, more like my DNSSEC or Tarsnap titles, or the first edition of Pseudo Mastery. I would like to have a break from writing doorstops like the SNMP and Jails books,
You can sponsor in print or ebook, and he provides links to both of them if you have a bit of money left. Remember, the print sponsorship includes everything in the ebook sponsorship, so you don't need to buy both unless you want your name to appear twice in the ebook. As we're in a pandemic, take care of you and yours first. I'm conflicted on offering sponsorships as so many people have lost their jobs. Several folks said they were going to send me money anyway, so I've opened these up. Do not send me money if you have any doubts about your financial stability. Right, this is a fair mention, and I think Michael will still get the sponsorship required to write this book. And I'm looking forward to reading it when it comes out.
Next, we have something a little different. Our producer, JT, has shared a picture of his open source retail box collection on Twitter last weekend, and it got quite a few responses, so there's a link to the thread. But you can see here a picture that we have linked of 5 or so shelves just covered in boxes of different OSs. There's, some FreeBSD stuff. That BSD Hacks there is a book, not a retail box of a disk. But you can see there's boxes of like Solaris, BOS. There's some Linux stuff, quite a bit of Linux. I think that stack of jewel cases on the one side there is more FreeBSD-ish. There's actually a link to a zoomed-in image of just the FreeBSD corner of the shelf, which, yes, you can see all that stack of jewel cases is all different retail versions of FreeBSD. And then I guess that one stack there is all BSD books, whether it's the FreeBSD handbook or installing and running FreeBSD or design and implementation of FreeBSD, BSD hacks, SSH mastery, ZFS mastery, advanced ZFS, etc. And then as a response to that, a number of people actually tweeted pictures of their collections as well. So if you want to see the collections of Deb Goodkin, Devin Teskey, or Jason Tubner, those are linked in the show notes. And I imagine if you check out the Twitter thread, there might be a bunch more. And, if you have a collection, add your picture to the thread, and we'll get to see all the collections everybody has.
What you're obsessively hoarding instead of toilet paper.
Somewhere in the corner on the floor in my office somewhere, there's an OpenBSD that I bought at a conference to support the OpenBSD project.
Yes.
So I have an OpenBSD in a jewel case somewhere. But that's about it. I've never really bought FreeBSD on media very often.
Yeah, we kind of came into this at the time when the CD-ROM business was already going down.
Like even when I did use a CD-ROM, it was like download the ISO and burn it to a CD or DVD and then use that.
Yeah, no fancy packaging.
But, I have a bookshelf of books, I suppose.
But yeah, people like to, dust them off and, order them chronologically and make sure that they get the proper care. And
well, yes. While I might never have used them, they are a very nice thing to have years later.
Yeah, very nice. So definitely send us a picture if you have a big collection of any Unix-y systems or BSD-specific ones. That's definitely worth adding to a future show. And then we have Tale of OpenBSD Secure Memory Allocator Internals, in this case malloc. This is over at a Beastie Boy with the O as a 0, of course.
And they say, hi there, it's been a long time since I've written anything after my last OpenBSD blogs, which he has links to there. So again, I started reading OpenBSD source code with debugger after reducing my sleep timings and managing to get some time after my professional life. This time I've picked up my favorite item from my wish list to learn and share, and that is OpenBSD's malloc. I will try to keep it into, an n-part series due to the lengthy content, and this series will mostly be focused on the user space code of malloc and friends. So first of all, I want to thank Otto Morbeek, Brian Steele, and Fabio Romano for helping me to understand malloc internals and clearing up some of my queries. We should start now. I've used the following sample code to start my journey with OpenBSD 6.6 stable. So they've written a little tiny C program that declares a character array called buff1 and then calls malloc on 8 bytes and now copies whatever you have in argv into that buffer and then frees it and then exits. Because they're using strcpy, not strlcopy or anything, whatever size your argv1 is going to get copied into that buff, but you only allocated that buff as 8 bytes, so you might run off the end of it. But, that's kind of the point of this example. So now compiled with libc with debugging symbols switched off, or with debugging symbols on and switch off the optimization by compiling it with capital O0 and -G. So they show how they do that. For printf style debugging, one can use dprintf or write system calls to print anything, but keep in mind that after installation with libc, the printf statement, it will dump lots of information for each and every binary. So installation steps is not to use malloc debugging. Anyway, goes into it. So they say just after the malloc from the sample code, it jumps directly into the function malloc from libc standard of malloc.c. And we see that that one basically calls the function omalloc with a prologue and epilogue wrapper around it. As explained by the developer, Otto, in a tweet here, it says the extra struct they allocate there contains all the meta information malloc needs to keep track of what page regions have been allocated, which page regions are in the free cache for the page chunks, and which chunks are free and which are allocated. As per the code given above, one can see after some basic initialization declarations, there's some macro called prologue and epilogue. It means that the same like it sounds, it basically sets up the stuff. So the function prologue, in assembly language programming, the function prologue is a few lines of code at the beginning of a function which prepares the stack and registers for use within the function. Here, instead of preparing the stack and registers, it initializes some other necessary malloc requirements, and then the epilogue cleans up after itself. So they show what those macros look like and what they're doing, and then they show the source code for the malloc init function, and then the omalloc init function, and digging through it.
In great detail, yeah.
So they run the program, and when they do run the stir copy, they see that they end up writing past the end of the buffer because they ran their program with the word AAAA, BBBB, CCCC, DDDD as the input, which is more than 8 bytes. And so when they try to write that, bad things happen. And then when they continue to see that the chunk canary corrupted, so when they try to free the memory, they see that it doesn't have the stack canary at the end to indicate that it hasn't been overwritten. So in the above debugging window, you can see that just after the malloc allocation, there are canaries with the value 0xdb, which are filled into the memory by the fill canary code snippet. Then after the memory allocation that is explained above, it copies the user-controlled input to that memory area. And after that string of 4 A's, B's, C's, and D's, you can see that the canaries are corrupted as it has been overwritten with the bytes from the C and D characters. Then later, when it calls free, which is responsible for validating the canary corruption, it calls abort and crashes the program because the canaries have been corrupted. So validation of canaries is user-related chunk is validated in the free function, but due to the lengthy content, it would like to cover the malloc friends library calls in a separate blog post. They also have some references. If you're more interested, they have obviously the malloc man page and a mailing list about it, and a paper by Otto about the new malloc in OpenBSD, but also BSD heap smashing paper. It's a Git code history, and old commit messages for some of that. The paper on PHK malloc that Paul Hennekamp wrote, and also a series on malloc by Adam Wolk and Duclair, and obviously the Twitter discussions, a bunch of which they linked in the article. And it sounds like they'll have a part 2 on the free call coming up soon.
Yeah, they liked reading the malloc library on OpenBSD or the malloc system call and learned a lot. So it seems like this is a way into more and deeper development secrets, and exposing them like this in a blog post is nice so that other people can also know a bit about the arcane knowledge hidden in there. So next we have a forum post from our good acquaintance, I would say, Patrick M. Hausen, on the IX Systems blog about how I learned to stop worrying and love SSDs.
This is basically the FreeNAS forums, or I guess it's now the TrueNAS core community page or whatever, but it's basically where the FreeNAS forums migrated to.
So Patrick writes, "Hi all, my home FreeNAS runs 2 pools for data. One RAID Z2 with 4 spinning disk drives and 1 mirror with 2 SSDs. Toying with InfluxDB and Grafana in the last couple of days, I found that I seem to have a constant write load of 1 megabyte per second on the SSDs. What the? So I run 3 virtual machines on the SSDs in total. 1 with Windows 10, 2 with Ubuntu running Confluence, a wiki essentially, with files for attachments and MySQL as the backend database. Clearly the writes had to stop when the wikis were not used at all, just sitting idle, right? Well, even with a full query log and quite some experience in the operation of web applications, I could not figure out what Confluence is doing productively, no doubt. But trust me, it writes a couple of 100 kilobytes to the database each second just sitting idle. So I moved the database server to a jail on my HDD pool, copied the databases, and reconfigured the two wikis. And the write load dropped significantly. But now I ran into startup problems. While in a single virtual machine, systemd can wait for the database to start up before firing up Confluence. Now I have the wikis in two virtual machines and the database in the jail, which seems to start after the virtual machines in FreeNAS. Of course, Confluence just complains and refuses to start instead of trying again after the next hit by some web browser like any stupid PHP application would. Oh well, maybe an artificial systemd service that checks for the listening MySQL port. And then I saw the light and did the math. 1 megabyte per second is huge, right? Well, not quite so, it turns out. It sums up to 86,400 megabytes per day. Let's make that 100 gigs because I can never figure out if we're talking binary or decimal, and there may be additional write jobs that someone or somebody's actually using the wiki of all things. The SSDs in questions have a TBW of 600. That's 600 terabytes of data written. And that's only the guaranteed volume. They won't break at 600 terabytes plus 1 byte, that or 5 years, Samsung says. So that's 6,000 days of constant abuse or more than 16 years. They will long be replaced by half of that time. So roll back to the 1 p.m. snapshot, opt for easier management, and simply don't worry about the writing. I do replicate the virtual machine Z-Vaults to my HDD pool, and that's it. Hope you enjoyed my story. I definitely learned something.
Of course, being myself, I'm still curious what Confluence is doing.
Right, that's still the application doing some crazy things there.
Yeah. But yes, it's definitely a thing that SSDs have a lot more endurance than they used to. But it also is a thing that you have to pick and choose the SSDs you use. I know of some people that picked overly cheap SSDs to use as the slog, the write log in ZFS, that only had an endurance of something like, 500 terabytes or something, whereas higher end enterprise stuff that you would recommend for that kind of workload have, write where leveling stuff for 10 petabytes, right? So if the drive can handle 10 petabytes over the course of 5 years, it's going to last longer under high load. But you have to remember with the slog on a database, if you're writing constantly a lot, then you are going to eat through that 600 terabytes. If you're doing a terabyte a day, which, in the end, that's not that much writing. If you're doing a terabyte a day, then that's only 600 days. That's not even 2 years, and your SSD is wore out, which can be a problem, but it's a really big problem when it's your slog.
Yeah.
And the ZFS wants to write all of the data to that first. Well, all of the synchronous data to that first. The other problem is, you were smart and you mirrored your slog with 2 SSDs that you bought at the same time that have the same endurance. And so they both were out at the same time.
Yeah.
And providing you, a very short window where, one was working and one wasn't. The nice thing about SSDs is when they do get to that wear out state, they tend to be, you can still read it, you just can't write to it anymore, which is usually a little less bad than, the drive just disappears or whatever.
I also like how he started with the story. Like, I toyed with Grafana and InfluxDB, and then suddenly the monitoring told me something interesting that I didn't know about before. So either it must be the monitoring wrong, or I just discovered something that I didn't know about. So this led into more interesting, explorations. So definitely a good thing to have monitoring. So yeah, thanks, Patrick, for writing that up for people to read. And our next item is a little bit similar in that regard. It's also about infrastructure. It's my infrastructure as of 2019 on changeown.me.
Yeah, changeown.me. It's Daniel Chakot's blog. And he says, I've wanted to write about my infrastructure for a while, but I keep thinking I'll wait until after I'm done the next thing on my to-do list. Of course, this cycle never ends, so I decided to write about the state at the end of 2019 as an arbitrary checkpoint rather than, yes, often when people ask me about it, it's like, well, I could do pictures and write up after I clean up some of the less good bits or whatever. But, using, in his case, the end of the year as just a checkpoint made it possible. Anyway, so he says, maybe I'll write an update in a couple of moons, once I get updated. Anyway, the goals of this infrastructure. The goal of my infrastructure is to run the services I need. While a lot of people in the home lab community experiment and play with software for its own sake, I actively use the stuff I host. When I stop, I kill these services, even though I'm not as proficient at this as Google is. These are my production systems. When one of them is down, I usually miss it. I kind of enjoy working on this infrastructure, but it's not that much. I used to enjoy it more, so I'm careful with the software I choose. I want to spend time on what I want to work on, not because I have to, something broke and it's infrastructure I depend on now. Consequently, I do my best to pick reliable, boring, and easy software. These are my kinks. Why do I host this myself? Mostly trust issues and the fact that I do care about sovereignty of the data. I tend to lock down services as much as I can, either cutting them off completely from the internet, for example, my IMAP server, or running them on a non-standard port and enabling some kind of two-factor authentication. I don't use a VPN, mostly because I haven't come up with a nice, clean option for that yet, so I restrict access to my services in different ways. For most things, I'm the only user, which is both sad, as maybe it's a waste of resources, and great, as it means, I don't have to worry about other people when I change things. A notable exception is my Mastodon instance, which is used by my cat. My machines are hosted in 3 different places. First one is at a hosting provider called Exoscale. The second one is at Vultr, and the third is at my house. All of them run either OpenBSD on its -current branch or the latest version of Ubuntu. At this time, that's Ubuntu 19.10. After a couple years of working on OpenBSD ports and packaging, I believe fresh software is better security-wise. They're all managed with Ansible. I began my Ansible repository 4 years ago, and it has about 1,500 commits in it. I wrote the Ansible to fit my needs rather than trying to make it generic, so it's not public because it probably wouldn't be helpful for you. I update the OpenBSD machines regularly to a newer OpenBSD snapshot, and of course that process has been automated. For Ubuntu, I prefer to just reinstall since they've managed by Ansible. They don't really have any persistent data in them. Reinstalling machines regularly helps spot missing pieces in my Ansible scripts. All the 3 sites are as standalone as possible, so as not to depend on each other. This is both so that, in case one of them gets owned or something, the attacker can't move laterally, but also so that if one is down, it doesn't impact everything else. One of them is a name server running OpenBSD and says this is my secondary name server, and it replaced an old secondary name server. And it's hosted at Vultr, and they talk a bit about that. Basically, it's running NSD, also running monitoring.
Oh, yes, no.
I'd not heard of that program before, but it's interesting. Then he has another machine. It's the main one of their infrastructure. A moment ago, your browser connected to it to get this page. That one's hosted at Exascale, and they talk a bit about that one. They host the blog using OpenBSD's HTTPD, front-ended by HA proxy. While I could remove the HA proxy, I like the software and I trust it. So they talk a bit about that. In addition to hosting the blog, it also does email. They switch from postfix to OpenSMTPD. And say, since I switched, they switched from OpenSMTPD to postfix. Since they did, they also dropped the OpenBSD spamd and have enabled FCRDNS in postfix. And they talk a bit about that. Another machine called Pancake, which is an APU2, which I'm assuming runs at their house. Yes. And that's the router there. And it also runs InfluxDB and Grafana to collect metrics with collectd. And then they have some machines called KVM1 and 2 that run Ubuntu, and those host VMs. And then they have another OpenBSD machine that they used for running Borg backup. And then they have OpenBSD VMs for a database and the web server, a Ubuntu machine doing some Docker stuff.
Okay.
But if you want to know more about what they're using and how they're doing it, it's all there in the blog post.
Yeah, it's a nice write-up to know, I have accumulated a bunch of things in the in the years.
But yeah, it's one of the points I plan to try to talk about in the home lab session that I'm hosting for BSDCan, which we'll talk about later in the show, is the, if you're going to keep certain stuff as part of your home lab rather than as part of your home network, you have to make sure it doesn't end up running critical services that are important to your household. You need to keep your infrastructure separate from your lab, because otherwise your lab machines end up running various bits of your infrastructure, and then you don't have a machine that you can blow away to do something within your lab, and that's kind of the point of the home lab. So sometimes you need to actually manage to separate your lab machines from your production stuff.
Yeah, one is the playground, the other one is more life critical.
Mm-hmm.
Okay, yeah. Good to know. If you have a similar home setup or want to contribute a little story about your home lab in the BSD space, then send it to us on our mail address, feedback@bsdnow.tv. We'll be happy to cover it if it's interesting. Okay, next up we have an installation of NetBSD on a Mac Mini.
It's a post on GitHub by Jorg Coleman.
Starts with, what's the problem? Over the Easter days, I was planning to resurrect my old PPC-based Mac Mini and to replace the old OS 10.4 with a newer but still BSD-based operating system. The first way was to install OpenBSD, which went quite smoothly and without great hassles. Fine. But as I made my first steps into the Unix land many years ago using NetBSD on my M68K-based Amiga, I was eager to also have a look at the current NetBSD versions. Phew, that was one kind of a ride. There are a few obstacles to overcome when trying to install NetBSD Mac PowerPC on Mac Mini, which made me learn a lot of the details about the hardware and about the boot process. So I thought I'd write a little bit about my experiences in case someone else, probably myself, ever tries to install this combination again.
Yes, it's kind of like we've talked about with Dan Langill's blog before. If you write down what you do, A, it's helpful to you later. B, if you need help from someone else, it's super helpful for them to know what it looked like before you started doing stuff and everything you've done to it. So it can help you and it helps you get help. And in the end, you can end up helping other people. So highly recommend whenever you're doing anything like this, write down everything you've done. And, in the end, you should publish it because it's helpful to other people. Even if you're selfish, do it for yourself because A, it helps you and save you time in the future. And B, it means you get better help if you have a problem.
Mm-hmm.
But, be like Dan and share it with everybody too so that they have the help they need too.
So they walk about anything starting from getting the install ISO and burning it onto a CD. Yes, this machine still has a CD drive because that was the latest and greatest way back when. Then they describe, going into the firmware to reboot the thing. For the next steps, you configure the system to always boot into OFW, and they provide all the commands how to do that. Installing the CD and formatting the root and temp partitions, as well as mounting it and writing the etcfstab file. Then to actually install the system, because at that point you made it behind most of the obstacles and now get to a place where other NetBSD users comfortably have been led to by sysinstall. But since this is a different box, you need to kind of do a bit of steps manually. Then you prepare the boot partition and finally set up open firmware for NetBSD boot to make that work. There's also instructions there. And at the finish line, you have, at least for the author here, a few iterations were needed to get there. Nevertheless, having NetBSD finally running again on real hardware feels a little bit like coming home after a long time. Great section as well. As I used the NetBSD 8.x installation CD burned some time ago, I'm now eager to prepare a smooth upgrade method. As these days, using CDs to upgrade as an upgrade medium seems a little bit outdated. I'm planning to do this completely off the net. It should be possible to define open firmware aliases to easier initiate the upgrade. Stay tuned.
Nice.
Oh yeah, very nice. And I guess if there's an update with more, then we'll cover it as well. So this part of the show, by the way, is part of a section. We're all quarantined at home, so let's install BSDs on various things. That is part of this section here. And the first one was NetBSD on a Mac Mini. And the follow-up item that we have is OpenBSD on the HP NV13.
Yes, so this blog post here, it says, my existing Keep It Simple Stupid install broke because I thought it would be a great idea to have the APK toolkit alongside my KISS package manager. It's safe to say that did not end well, especially when I installed and then removed a package. With a semi-broken install, and I didn't feel like fixing it, I figured, let's give OpenBSD a try instead. And I did. So ran into trouble booting off the USB initially, but that turned out to be a faulty USB stick, not OpenBSD's fault. These things aren't built to last, sadly. So flashed a new stick, booted up, and setup was pleasant, very straightforward. Didn't really have to intervene much. OpenBSD is mostly just keep pressing enter. After booting in, I was greeted with a very archaic looking FVWM desktop. It's not the prettiest thing and especially annoying to work with when you don't have your mouse set up, i.e. no tap to click. I needed wireless and my laptop doesn't have an Ethernet port, but USB tethering just worked, but the connection kept dying. I'm not sure why. Instead, I loaded the IWM firmware from here and loaded it up on a USB stick and copied it into the etc firmware. After that, it was as simple as running the firmware update command and the firmware was auto-detected and loaded. In fact, if you have working internet, the firmware_update tool will just download it for you. Then configured wireless is painless, and I'm so glad that there's no WPA supplicant horror to deal with. So they just did, ifconfig, IWM, network ID, SSID, and then the key. They also show how you can set that up with your, so that happens at boot and so on. By now, I was really starting to be exasperated by the FWWM, or FVWM, and I decided to switch to something nicer. I tried building 2BWM, which is the previous window manager they liked, but that failed. I didn't bother trying to figure out why, and just installed CWM. After all, people sing high praise for it. And boy, is it good. The config is a breeze and actually pretty powerful. And there's a link to theirs if you want to see what it is. CWM also has a built-in launcher, so D menu isn't necessary anymore, and you can read the man page for how that works. The touchpad was pretty simple to set up. BSD has WS-Cons CTL, which lets you set up your tap-to-click, mouse acceleration, etc. However, more advanced configuration can be achieved by getting Xorg to use the Synaptic driver. Just add the 70-synaptic.conf to your xorg.conf.d, and they have an example of that. And then they also set up suspend and hibernate just worked, thanks to the power management stuff. Suspend on Liz close just needs you to set the sysctl to say what to do when you close the lid. Impressions. I already really like the philosophy of OpenBSD, security and simplicity, while not losing out on sanity. The default install is plentiful and was just about everything you'd need to get going. I especially enjoy how everything just works. I was pleasantly surprised to see how my brightness and volume keys worked without any configuration. It's clear that the devs actually dog food on BSD. Oh, and did you notice all the man page links I've littered throughout this post? They've got man pages for everything. It's ridiculous, and they're very thorough. The Arch Wiki is good, but it's incorrect at times or simply outdated, whereas OpenBSD's man pages, although catering only to OpenBSD users, have never failed me. The performance and battery life are fine. The battery is in fact identical, if not better than it was under Linux. OpenBSD disables hyperthreading and SMT for security reasons, but you can manually re-enable them if you need the performance. The package management is probably the only place where OpenBSD falls short. Package_add isn't particularly fast considering it's written in Perl. The port selection is fine, but I've yet to find something that I need, and it's not there. I also wish they debloated the packages. I now have dbus on my system thanks to Firefox. I appreciate the fact that they don't have political document, and they have some links about that. They're also looking at VMD, the hypervisor, to see if they can get their Linux environment going under that. Perhaps that'll be their next post. And then they include some ASCII art of a blowfish.
Okay. Yeah, that's another successful installation. Very good. The next item we have is NetBSD installation on a vintage computer over at rs-online.com. And at first they talk a bit about, NetBSD and its legacy in the BSD space. In fact, they write as of 2019, NetBSD supported no less than 59 hardware platforms across 16 different instruction sets, ranging from physical, enormous classic VAX computers to now retro PDAs, along with a great deal of other hardware in between, both esoteric and more common. So to find out if your hardware is supported, check the ports page. There's a link to that. Each port will have a set of release information, so it's installation notes. For example, here are those for installing NetBSD on a PowerPC Mac. And this one that they are using here is a ThinkPad X60S, itself now becoming something of a classic computer that was used to run the restore system. It wasn't necessary to actually install anything onto its HDD, and instead a bootable USB stick was created using an image downloaded from NetBSD's website. In the same directory, there's also an ISO file, which can alternatively be used to burn a bootable CD. NetBSD also provides complete instructions for NetBSD/Cobalt for the CD how-to. And so the restore system should be connected to the cube via an Ethernet cable. The how-to suggests using a crossover cable, but this should only be necessary if the restore system computer is really quite old, since Ethernet ports have generally supported auto MDI-X crossover for some time.
I love how they got, a system install modules.tgz on the little LED display.
Oh, yes, in the back, yeah. There's also a section about the configuration you would do on a couple of initial setup steps, like setting a host name in rc.conf and similar things. And then they go into installing the software, how to use the NetBSD package collection, package source. And they wrapped up with, we've barely scratched the surface of NetBSD, and there's a great deal more that could be written about its fascinating history, along with neat features such as multi-architecture support. And while its design means that it enjoys a local user base and a committed development community. It's really great that NetBSD can be used to bring vintage computer hardware to life, and not only that, but via a modem OS that can run, or modern OS, sorry, not modem OS, modern OS that can run familiar software, CPU and RAM permitting.
Yeah, that's interesting because it's kind of what NetBSD came about for in the first place, was these big iron machines where the manufacturer didn't make software for it anymore. And so being able to run a version of BSD on it was really NetBSD's thing. And they managed to keep doing that.
Yeah.
I think the only confusing thing is calling the support for the different architectures ports, because we kind of also use that to be porting software to the OS. But yes, it's the same term applies to porting the OS to different hardware. And so, you says go to the ports page and see if your hardware is supported. Sounds weird when you're used to talking about the ports tree and it's the software for your OS. But in this case, it's whether the architectures page is basically if NetBSD works on that hardware. And, generally the answer is, of course it runs OpenBSD or NetBSD.
And while we're on the subject of interesting installations and home setups, we should mention again the BSD CAN Home Lab panel recording session that happens on May 5th at 1800 UTC.
Yes. So as you might have heard, this year BSD CAN will be an online conference instead of in person for obvious reasons. But rather than a talk this year, what I had submitted was this idea for having a panel about home labs. So I invited a couple other people who do things like that, but in different ways than I do, together, and we were going to, sit in front of the audience and talk a bit about it and answer some questions. Obviously, that doesn't fit so well with the idea of just pre-recording the video and publishing it like we were going to see for most of the talks at BSD CAN. So to try to recreate the environment of an audience firing questions at us, we're going to do it by scheduling it online and having the live stream in a chat room. So if you are able to, please come Tuesday, May 5th at 2 p.m. Eastern or 1800 UTC. It's the same time we normally record BSD Now at, but this is on a Tuesday instead of a Wednesday. The link is in the show notes there, and that page has the live stream in the chat room, and you can start asking your questions, and we'll have a moderator. Actually, the producer of BSD Now, JT, is going to do that. So he will read the questions out from IRC to our panel, which will be myself, Michael W. Lucas, Nicholas Sizing, and Michael Dexter, and we will provide our different views on your questions and so on. I aimed for a diversity of experience with home labs, from people that, their home lab is a couple of spare laptops, through, me having a full rack of machines in my basement, where I've kind of almost blurred the line between a home lab and a work lab. But, trying to cover all the possible considerations, even down to I need a life partner approved home lab. I can't have too many cables everywhere. It can't be ugly. Or, a problem I normally don't have to deal with is I need a 10 gigabit switch that isn't so loud that I can't have it sitting on my desk beside me. It's like mine's in a rack downstairs. I've never considered how noisy it is. But if your home lab is in your apartment or something, you probably want something that doesn't make a droning noise so loud that you can't think. And so we're going to try to cover everything. But if you have questions, or even if not, please do come and watch that live and help us kind of recreate the conference experience. And then that will get put together and become part of BSD CAN when that comes out.
That's very nice. Better than having nothing, because the conference was moved to an online thing. So definitely look forward to the responses.
We figured this will work a lot better than recording a Zoom call of just the four of us trying to come up with things to say. This will keep the feel of the panel. We've done a couple of panels at different BSD conferences now. Like I did a ZFS one, the last two Meet BSDs, and it was really good, and I really liked it. And I wanted to kind of recapture that type of thing, but on a slightly broader topic instead of just talking about ZFS. Not that I have any problems about just talking about ZFS for an hour, but I'm looking forward to being able to still do this in this way. And basically, based on the FreeBSD office hours things we've also been doing, which I guess I should also mention. If you go to the FreeBSD wiki, there's a new page there, office hours. And on that, we have the 2 office hours we've already had in April. And there's videos to those, and also the scheduling for some future ones. And the general idea there is to bring together a bunch of developers and users to answer questions. So the idea, similar to the old ZFS, OpenZFS office hours that happened in the past, is we schedule a time, we get a host or a couple of developers together, and they can answer people's questions for that hour. The first one we did worked out really well. I think we had about 60 people total in attendance and answered questions across a very wide spectrum of different levels, from like really in-depth stuff with the CAM layer, developer to developer questions, down to just simple user questions, and even just, what's your favorite feature of FreeBSD or whatever. And it worked out very well. The second one, we tried a different time slot to try to be more in the evening for people in North America and to allow people from Australia and Asia to join. Fewer people joined, but it was still good. And there's also on that page a poll to vote for what time would work for you. And then it's open if other people would like to volunteer to host one of these or be one of the hosts of it. We'd love to get more of these together and have it be a regular thing. So when people have questions, they have somewhere they can go. We can't promise you'll get an answer, but usually you at least get a pointer in the right direction. And we tried to, spread that tribal knowledge out wider.
And you never know who is also in the chat room who's interested in picking up something or just talking to you because you're in like a beginner or an advanced stage of your BSD journey. And you never know what happens. There could also be some things happening just because you joined a channel at the right time. Okay, since last week we announced this the first time, we should repeat this one more time, or so that people can actually make updates and know about this and don't get surprised. BSD Now is going independent. So as kind of a backstory here, so after being part of Jupiter Broadcasting, since we started back in 2013, BSD Now is moving to become independent. So we, of course, thank the people who have been with us on this journey from Jupiter Broadcasting and the successor Linux Academy for hosting us for so many years and allowing us to bring you over 100 episodes. That's quite a lot without advertisements in the actual parts and segments. So for you, the listener, this doesn't mean much of a change, just for us behind the scenes. Not much will change. Just make sure that your subscription to this podcast via any RSS feeds or any other podcasting applications that you have will point to bsdnow.tv rather than the Jupiter Broadcasting ones. Otherwise, you will miss the next episode. Of course, we will do weekly episodes as always. And if there's something new on our side that you should be aware of, we'll mention it, of course, on the website and in the podcast.
So yes, again, thanks to Jupiter Broadcasting and Linux Academy, and we understand why aren't able to keep the show going anymore. But don't worry, we will keep the show going anyway.
That's definitely our goal and aim, and we will definitely do our own thing independently, just the way we did it with big companies behind it. So yeah, thanks again for the people who've been with us on this journey, and just to let you know, update your RSS feed so you get the latest and greatest updates from us. In this part of the show, we would have the feedback and questions, and we got feedback and questions from you, of course. We just figured, okay, this show is already quite long this time. We figured we should just cover one, but there will be more in the future, of course. So don't let this part get dry, and send any feedback that you have about the show, any ideas for topics or things you always wanted to know that we haven't covered yet. Send all of this to feedback@bsdnow.tv, and then you will appear in a future episode in exactly this spot. So we have taught this week about claim from Linux Tech Tips about ZFS. And that sparked our interest enough to answer that. So Todd goes like the following. Hi guys, just wondering if this video's finding is legitimate. So there's a link to a YouTube video. In short, he claims disabling the ARC cache is a good thing and will improve performance. I don't see any scenario when this would be good. Have you heard of any case where this complaint about latency between interrupt requests and CPUs is valid? It seems to me that this NVMe array could overload the CPU, but it seems more reasonable that disabling hyperthreading would correct this issue. Any thoughts? Or is this looking like a legitimate limitation of ZFS queuing?
It can depend. I've never had access to a machine with that many NVMe drives to need to look into this. Luckily, in ZFS, this is easy enough to do. Like, you can just ZFS set primary cache equals none and compare before and after and see. I'm guessing more likely you'd actually want to look at tweaking a couple of the other options to see, even if it is maybe the ARC cache seems to be the problem, it might actually be either the ABD feature, the ARC buff data, which constructs the ARC of scatter-gather lists of 4K pages rather than linear allocations to help with fragmentation and memory pressure. But in really high performance, that extra copy can end up slowing things down, and maybe disabling that will make a bigger difference, although I don't think it's possible to disable it on Linux, only on BSD. The other one is the compressed ARC. You might try disabling the compressed ARC because it might be that, the NVMe is so fast that the step of decompressing the blocks is starting to slow it down. But there could also be some limitations in ZFS's queuing. I know there's been a bunch of work to improve performance with NVMe. As suddenly the disks go from being able to do hundreds of IOPS and hundreds of megabytes a second into hundreds of thousands of IOPS and gigabytes per second, obviously there might be some more work to be done there. But most likely, disabling the ARC is a workaround to a problem rather than the solution. Because, in the end, the RAM is still going to be faster than the NVMe, but you might decide that the stuff on the NVMe is fast enough that maybe skipping that might help. I don't know. I know there's also some work going on upstream in OpenZFS for, I think, DirectIO to be specifically for reading and writing without going through the cache. Although that's more about not pushing valid data out of the cache to make room for this data you're not going to use a second time. So choosing not to cache something that way, rather than because the cache is slow, you're doing it because the cache is making this other stuff fast and we don't want to slow it down by making it cache something we know we're not going to use a second time. So I wish I had a test system to be able to track this problem down and be able to tell you for sure whether it's, a particular way the ZFS does queuing that isn't the problem, or if it's a specific feature of the ARC, or if it was just some tuning. Because it could also be just that there's a couple ZFS tunables that Linus needs to tweak in order to handle the fact that, in general, NVMe devices are different than regular hard drives and even SSDs in that, with a SATA interface, the drive only executes one command at a time. Now, with native queuing and so on, you can give the drive multiple commands, and the SSDs can usually use this to try to get some work done. But the commands always complete in the order they were sent. Maybe not. Actually, it depends. Anyway, the big difference is, in general, a spinning hard drive does one thing at a time, whereas an NVMe usually can support up to doing 63 different commands at once, and the newer drives can start bumping that number up, where you can have a lot of stuff happening at once. And in fact, where often you need to give it that many different things to do at once in order for it to get all of its performance. If you give it one thing at a time, you're only going to use, 1/32 of the available NAND dies to read from. Whereas if you give it a larger amount of work, it can spread that out across the parts of the flash and get more work done in the same amount of time. So it might also just be that there's some tweaking that needs to be done to make that NVMe array work well. And like you said, it could be hyperthreading. If they're just scheduling more interrupts or there's just too many threads competing, they're spending all their time contending on things rather than actually doing the work.
Right. Yeah. Test multiple avenues you can explore where this is coming from. Okay. Hopefully that gave you some pointers and some ideas what to do and what not to do, or just wait until ZFS code has grown a feature to accommodate for that.
Well, if you have one of these NVMe arrays, like, with a lot of NVMe, then, I'd be happy to help try to work out what the problems are and get them fixed. But I don't know if anybody other than Linus has an array with that much NVMe and is running into these problems. I've not heard of anybody else running into these problems.
Yeah, definitely recording or reporting that upstream to the ZFS folks is good. And if you can provide some testing or try out some patches, that would definitely help bringing the upstream software into shape to make it work more smoothly. So yeah, that pretty much wraps up our feedback and questions. Thanks, Todd. And that also ends this week's episode of BSD Now. Don't forget to send us anything that you found on the web that's BSD related, that should be interested to other people and included in a future episode, to feedback@bsdnow.tv. And we'll be right back next week in the usual manner. Yeah, stay safe, stay healthy, and wait until this episode has a new iteration. Comes out next week.